Hello everyone, I'm Siddharthan. Currently, we are in the 8th module of our hands-on machine learning course, and in this 8th module, we are discussing about the topics such as cross-validation, hyperparameter tuning, and model evaluation. In the previous video, I explained you what is meant by hyperparameter tuning, and we have also discussed the concept of GridSearchCV and RandomizedSearchCV. If you haven't watched that video, I'll give the link of that video in this video's description, so you can watch that video before this one so that you get a clear understanding of the conceptual aspects. Okay, so hyperparameter tuning is that, so we are just basically tuning the hyperparameters. If you consider machine learning models, there are different hyperparameters. So if you take a support vector machine classifier, there are hyperparameters such as c value, kernels, etc. So for a random forest classifier, there are hyperparameters like n estimators. Similarly, there are different hyperparameters for different model, and each of this hyperparameter can take any values. So our goal is to determine which parameter values is the best for our use case. So best in the sense, so like if you use that parameters for your model will have the highest accuracy. So that's the idea behind this. And in this hyperparameter tuning, we will try to find that particular parameter which is the most optimum one. Optimum in the sense, as I've told before, it will give us the highest accuracy. And the two techniques to do this hyperparameter tuning are GridSearchCV and RandomizedSearchCV. Where in GridSearchCV we will try different combinations of parameters, whereas in RandomizedSearchCV we will randomly choose some parameter values and do the validation and so on. So you will understand this in more detail as we implement this. And for this hands-on part, we will be using the breast cancer dataset that we have worked before, so that we get a better understanding of the data. Okay, so I hope you have watched that video. If you haven't watched, you can also watch that one if you want to understand what are all the different processing we are doing in this dataset and how to build a predictive system for this breast cancer use case. Okay, so I'll give the link for breast cancer classification video in this video's description. You can check that out. So I'll just quickly explain what are all the basic processing things that we do on this dataset. So the first part is importing the dependencies, where we import the required libraries and functions, and I am sure that at this point most of you would know this. And the two main important things that we are importing are GridSearchCV and RandomizedSearchCV, which we are going to use in this video. Okay, so we are importing this GridSearchCV from sklearn library, and sklearn library has a module called as model selection. And this is in this module, there are various functions like train, test, split, and so on. Okay, and GridSearchCV also comes under this model selection, and again RandomizedSearchCV is also present in this model selection. You can also search the documentation of GridSearchCV and RandomizedSearchCV and just give a read on it to get some understanding of it. Okay, so next the basic things are just loading the data set and loading it to the pandas data frame, and this data set is present in this sklearn.datasets. So from that we are loading our breast cancer data. So you can see the data here. So this is in the form of a dictionary, where the this data array contain all the feature values, and the target array will contain all the targets 0 or 1, where 0 represents malignant and 1 represents benign. So you can see here, so 1 means benign and 0 means malignant. So these are all the labels that we have, and these are all the features names. So the target names is malignant or benign, and the feature names are given here. So we have about 30 features in this one. And now we are loading this data into a pandas data frame to do easier analysis and processing. So we are naming this data frame as data frame, and pd.data frame is the function that we are going to use in order to create this data frame. And the data for this particular data frame will be this breast cancer data. So you can see, so this is what we are loading. So data is nothing but all the values of the features that we have, and then we are giving the feature names. So this is basically mentioning the column names, and when you print the first 5 rows of the data frame using the set function, you will see this. So the first 5 rows, and we have about 30 columns, and you can also see the column names which we have given using this feature names. Okay, so columns is equal to feature names will load all these names of the features and put it in the column names of the data frame. So that is what is happening here. And now we are adding the target column to our data frame. As I've told you before, this target array contains either 0 or 1, where 0 being malignant and 1 being benign. So the primary use of this dataset is to build a machine learning model, to train a machine learning model, so that it can classify the data points into either benign or malignant. So we are adding this target column to our data frame, and we are creating a new column called as label, and that is where we are going to load this data. Now if you print the first 5 rows, you can see the last column, which is label. It will contain either 0 or 1, but it won't be present there in the first one. Okay, so you can see that here. and we are just checking the shape. So how many rows and columns are there? So totally there are 569 rows, which means there are 569 data points are there. That means like this data is for 569 different patients, and 31 columns, where first 30 columns are our features and the last column is our label, which is basically a target column. And we are just checking whether there are any missing values are there. So these are just basic processing things that we usually do in all the data sets. So we are just checking whether there are any missing values. So we have 0 in all the values, and we are just checking the distribution of the target variable. So how many data points are there for class 1 and how many data points are there for class 0. So you can see here class 1 has 357 data points and class 0 has 212 data points. So there is some imbalance in this data set, but this imbalance is not like very large. So there can be data set where there is no balance in the distribution of the class. Say for example, there can be like two classes 1 and 0, and the number of data points for 1 will be 500 and the number of data points for 0 will be just 100. So there is a 5:1 ratio. So there is a clear imbalance and a large imbalance. So in that case we have to do some more processing, but in this case the imbalance is not that much high, so we can use this data directly itself. So as I've told you before, 1 means benign and 0 means malignant, and you can go to sklearn.datasets. So you can go to this sklearn.datasets documentation and check this load breast cancer data. So in that case, in that documentation you will you can see the details about the features and the target and all the things, and you will also see there one represents benign and 0 represents malignant, so it will be represented there. And now what we are doing here is like we are splitting the features and target. So all the features will go to the variable x, and the target, the label, will go to the variable y. So data frame dot drop. So we are just basically dropping the label column and storing the other columns in x, and we are storing the last label column in y. So this is what we are doing. So like we are not going to do much analysis and processing and all of those things, because the idea of this particular video is just to show GridSearchCV and RandomizedSearchCV. So we won't be going into detailed analysis. So if you want to learn detailed analysis of this data set, you can watch my exploratory data analysis video. I linked that video in this video description. You can check that out if you want. But here we will be working on only GridSearchCV and RandomizedSearchCV. So here you can see that we are printing x and seeing that it doesn't contain the label, and y will contain all the labels. So the next step is converting. So this is basically in the form of pandas data frame, and now we are going to convert it into numpy array so that it is easier for our processing. So for that we are going to use the numpy library, which we have imported as np, and we are going to use the function as array, and this will create this data frame x into array, and that array will again be stored in the variable called as x. So this is where we are going to use our GridSearchCV. So after this point, so I'll just create a text here and name this as GridSearchCV. So basically what we are doing in GridSearchCV is that, so I'll also put create another text, and I'll mention what we are doing here. So GridSearchCV is used for determining the best parameters for our model. Okay, so in this case we will be using a support vector classifier. So you can see here, so we have imported the support vector classifier from sklearn.svm. So in this we will be giving different values for the hyperparameters of svm. So you can see the different hyperparameters that we have. So we will be taking C and kernel, and we will be doing this hyperparameter tuning. So once you watch this video, you can try this SVM classifier, or you can also try other models like random forest classifier, and you can do hyperparameter tuning in those models as well. So in this case, we will consider only the support vector classifier. Okay. So now I'm going to load my GridSearchCV function. So okay, so before that, let's just load our support vector classifier. So loading the SVC model, where SVC stands for support vector classifier, and let's create a variable called as model, and let's load the instance of this SVC. Okay, so which we have imported. Now we have to create a dictionary with hyperparameter values. So I'll just create a comment here as hyperparameters, and I'll name this dictionary as parameters. Okay, so this parameters is equal to We know that in Python, the dictionary is enclosed in curly brackets. So I'll just create the key value pair, which is kernel. And for this kernel, we can try different values such as, so let's try the values. Linear. So subprotected classifier as linear kernel, RBF kernels, and so on. So I have explained this in the subprotected classifier from scratch videos. So you can watch that one if you want to understand about this linear kernel, RBF kernel, and so on. And sigmoid. So these are all the different kernel values that we are going to check: linear, poly, RBF, and sigmoid. And the next hyperparameter that we are going to choose is C. Okay, so C is equal to, so in the previous video again I have explained you what is meant by this C as well. So I'm going to take different values such as 1, 5, 10, and 20. So these are all the different C values I'm taking. So the significance of the C is that, like, if you have a very small C value, then like the model doesn't allow any misclassifications to occur. So if you just split the data using hyperplane, so we know that in subprotected classifier we classify or we segregate the data using hyperplane. So if you have a very small C value, then there won't be any mix of classes, so there will be a clear cut hyperplane. Whereas if you have a larger C value, then there will be some mixing of these classes, because the margin will basically be larger. So that's the idea of the C parameter in subprotected classifier. And I'll run this one. So we have just basically created a dictionary called as parameters, and this parameters, so we know that dictionary is basically a key value pair where we have key and specific values for that key. So in this case, kernel is one key, and this particular list is the value for this key called as kernel, and again C is another key, and the value for this key is 1, 5, 10, and 20. Now what we are doing here is, so we are going to use this GridSearchCV, and we are going to determine for which combination of these parameters we are getting the high accuracy. So basically what we will do is, first we will take subprotected classifier with linear kernel, and for linear kernel we will take C value as 1, and then we will try to train our model and print the accuracy, and then we will take this again linear kernel with C value as 5, after that linear kernel with 10 and 20 and so on. So this will be done for linear, poly, RBF, and sigmoid. So all the combinations of this kernels and C value will be executed, and we will train our model with these different combinations of kernel values and C values, and we will determine which values are the most optimum one. Optimum in the sense that will give us the highest accuracy, and this is what we call as grid search, because we will be checking all the parameters, all the combination of these parameter values. So hence it is called as a grid search, where we are checking for all the values in the grid. Whereas if you consider, or if you think about this randomized search CV, instead of trying all the combinations of all the parameters, we will randomly choose some parameters and train our model. So the reason is, in some cases the data set will be very large, and training your model will take a huge amount of time. So in that case we cannot try all the parameters possible. So in that case we will randomly choose some parameters. So that's the difference between GridSearchCV and RandomizedSearchCV, where in GridSearchCV we will try all the combination of values, and in RandomizedSearchCV we will randomly choose only certain parameters, and try to find which parameter combination has highest accuracy. So that's the idea. So I'll just create a text here as grid search. Okay, so grid search, and I'm going to create a variable called as classifier, and this is where we are going to load our GridSearchCV and our model, which is subprotected classifier. So I'll call the GridSearchCV function GridSearchCV. So if you remember, we have imported this GridSearchCV from sklearn.model selection, which we have discussed before. So we are going to use that, and the parameter values of the GridSearchCV, or the attributes value that we have to give to this GridSearchCV, you can see here. So estimator and parameter grid and so on. So we are going to give those things. So the first thing will be the model that we are going to test. So model parameters, and then we are going to give CV is equal to 5. Okay, so the first attribute that we have to mention is model. So because so model is nothing but our subprotected classifier. So for this model, for this subprotected classifier, I'm going to apply this insert CV to determine the optimum parameters, and the parameters that I'm going to check are this. So parameters is nothing but our dictionary that we have created here, right? So where we have different kernel values and different C values, and CV is equal to 5. So CV is nothing but cross validation. So like you can give the CV value as 3 or 10 or whatever you want. So this is basically the number of folds that we have in our data set. So as I've explained in the previous video, in this particular module, we have discussed what is meant by this cross validation. So in cross validation, we will split our data into different folds, and each time a particular fold will be used as your test data. So CV is equal to 5 means 5 folds of the data will be splitted. So that's the idea. So you will get 5 accuracies, and we will take the average or mean of those 5 accuracies as our final accuracy value. So this is called as GridSearchCV. So first we have to specify the model that we are going to use, and what are all the different combinations that we are going to try, and what is the number of folds for your cross validation. So I'll run this. Now we need to fit our data to this. Okay, so X and Y. So we know that X is our features and Y is our target, which is our labels. So this is like fitting the data to our model. So if you note, we have not splitted our data into training data and test data. So the reason is the GridSearchCV automatically do those things. So it will again, so in this case we are actually not doing train test split, but we are doing cross validation. So instead of that, we are doing this cross validation. So we don't need to split this train and test data. So once we do all these steps, once we find the optimum parameters, after that only we will split our data into training data and test data. I'll show you how that works. So first, now let's train our data. Okay, so classifier. So classifier is nothing but our GridSearchCV function. So you can see here classifier dot fit. So fit X and Y. So when you mention this, classifier dot fit, so it will load the model. So in this GridSearchCV, we have used this model, and this model is nothing but SVC. So this data X and Y will be fitted to the subprotector classifier model, and each time the different combinations of this kernel and C values will be tried, and we will be given the different accuracy values. So I'll run this particular cell classifier.fit X and Y. So let's see. So this probably is taking some time because like we are trying different combinations. So the training is going to take some time. So it may take some time, less than a minute or something like that. So once this training is complete, we need to print the result of this GridSearchCV. So for that, you need to mention the name of the, so we have loaded this instance of GridSearchCV to this variable called as classifier. So mention classifier dot CV results. Okay. So CV results will print us the result of this GridSearchCV, which is basically the accuracy and other search values. So as you can see here, the code is still running. So let's wait for it. And so the process will be the same for the randomized search CV as well. So all the things are same. So the only difference is that instead of trying all the parameter values, we'll be just randomly choosing certain values. So the reason is that, as I've told you before, there can be large data set, and you won't have resources for that much amount of magnitude. Like you won't have the time to train your models for that many different combinations, or you may not have the RAM or the computation power to do it. So in those cases, instead of trying all the different values, we will randomly choose some values so that the training doesn't take that much amount of time. Okay, so that's the idea. So I think this is like taking a long time than usual. So let's wait for it. Okay, so GridSearchCV estimator CV param grid. So param grid is nothing but grid is nothing but all the possible values that we have. So in C we have the values like 1, 5, 10 and 20. For kernel we have linear, poly, RBF and sigmoid. Okay, so now so basically what happens is, as I've told you before, first the GridSearchCV will take the C value as 1 and the kernel value as linear, and then it will train our X and Y with this, and it will give us the cross validation result. So after that, it will take this C value as 1 and kernel value as poly. So for C value as 1, we will be trying linear, poly, RBF, sigmoid, so individually. So after this is done, we will take C value as 5, and again, so all this linear, poly, RBF, sigmoid will be trained separately, and all those results will be stored. So for printing that result, we need to mention the function name. So basically the classifier or the variable into which we are loading this GridSearchCV, and mention this .cv results. So let's print this. This will give us the result. So this is the result that we are getting. So you can see the different combination that I have told you. So the first combination is C is equal to 1 kernel linear, and then we have C is equal to 1 kernel poly, and 1 RBF, 1 sigmoid, and then we have C is equal to 5 linear, 5 poly, 5 RBF, and so on. So all the different combinations are tried for it, and we have some rank test score, split 0, split 1, split 2. So these 5 splits. So split 0, split 1, split 2, split 3, split 4. So we have 5 splits here, right? So these are nothing but our cross validation folds, cross validation splits. And as I've told you, you will have 5 accuracies, and for this we will try to find that mean accuracy values. And so as you can see here, this is like the value for the different parameter combination. So that's why you have these many accuracy values. And now, so this is like not like it is hard to interpret these values. So for this, what we can do is we can load all this data, we can load all this information to pandas data frame, so that we get a clear picture of what all these things means. So I'll create a text here as, okay, as loading the results to pandas data frame. Pandas data frame, and result is equal to pd.data frame. So in this pd.data frame, we need to mention classifier.results. So we know that this all the results of this GridSearchCV are stored in the CV results, right? So I'm copying this and pasting. So classifier is our GridSearchCV, CV results is where our all the values are stored. So before that, what I'll do is I'll just try to print what is the best parameters that we have. So out of this different combinations, we are going to print which is the best parameter, and for for that best parameter, what is the accuracy that we are getting. So this step will be best parameters. So we are going to print the best parameters for our support vector classifier, and I'll create a variable called as best parameters, which is equal to classifier dot best params. Okay, now you can see, so when we run this classify.cv result, this result of this GridSearchCV will be printed. And when we run this classify.best params, so out of all these combinations, the classifier will return us for which parameters we are getting the highest accuracy. So that's the idea. And now those parameter values will be stored in this variable. And now I'm going to print this variable, which is my best underscore parameters. Let's see what is our best C value and best kernel value. Okay, so as you can see here, the best parameters are C is equal to 10 and kernel is equal to linear. So basically what this means is, for this data set, if you use the C value as 10 and kernel value as linear, you will get the highest accuracy. And for other combination like C as 1 or 5 or kernel values like RBF and poly, you won't get that much of high accuracy. But when you use C is equal to 10 and kernel is equal to linear, you will get the highest accuracy. And that's the idea here. And now let's try to determine what is that highest accuracy that we are getting for C is equal to 10 and kernel is equal to linear. So this will be for highest accuracy. So I'll create a comment here as determining the highest accuracy for this particular thing. And let's create a variable called as highest accuracy. So this highest accuracy is equal to classifier dot best score. Okay, so you can save this code, you can save this template for your other use cases. So you will probably be working on different use case, so you can just understand what are all the steps we are doing here, and you can implement those steps in order to do this GridSearchCV for your particular use case and so on. So best score, and now I'm going to print my highest accuracy. Let's see. So the highest accuracy that we are getting is 95.2%. So 0.952 represents 95.2%. So what this basically tells is, for this different combination of C and kernel values 1, 5, 10, 20 and linear, poly, RBF and sigmoid, the best parameter combinations are C is equal to 10 and kernel is equal to linear, and the highest accuracy that we are getting for this parameter combination is 95.2. And now we are going to load this information into a data frame to get a better understanding of this. So let's run this one. So we are just creating a data frame. We are naming this as a result, and we are using this pandas library, and that we have a function called as data frame to create a data frame, and the data for this will be classifier.cv result. So let's run this. And now let's print the first 5 rows of this data frame. So result dot date. Okay. So you can see mean fit time. So how much time you are like the model is taking to fit to the data. So standard fit time. So this probably is the standard deviation and so on. So mean score time, again the standard score time, param c. So this is the different combination of values. C is equal to 1, param kernel is equal to kernel is equal to linear and so on. So we have split 0 test accuracy. Okay. So like what this value means is like what is your cross validation accuracy for parameter value of c is equal to 1 and kernel is equal to linear, and this is the split like second split. So split 0 is our first split, split 1 is our second split, and so on. So totally we have 5 splits because we have mentioned this cv is equal to 5 here in this GridSearchCV function. So we have mentioned c is equal to 5 and so on. So we have various features or various metrics, right? So here the things that are important for us are the parameter values. So the C parameter values is important for us, kernel parameter value is important for us, and what is the test score. So if you see this mean test score, so what is the average test data accuracy for each of this different combination of parameter values. So I'm going to choose those values alone. So grid search. So I'm just shrinking this data frame with only certain columns. So grid search result. So we are creating grid search result, and this grid search result is equal to result of. So when you mention this two square brackets and mention the columns, so the columns from this original data frame will be loaded to this grid search result. So the columns that I'm going to need are this param c. Okay, so this is one column, and the second column that I'm going to take from this larger data frame is param kernel, which is the different values for our kernel. And finally I'm going to take my test data, mean test accuracy. Okay, so mean test accuracy. So these are all the different columns that we are taking, and let's run this. So now we are just creating a different data frame called as grid search result, and this is nothing but in this result data frame. So this result is our original data frame which contain all the results of grid search CV, and in that we are from this original data frame we are choosing the column param c, param kernel, and mean test score. And now I'm going to print this entire data frame. So let's put this here and run this. So you will see that, so what this basically tells is like for parameter, like when you give c value as 1 and the kernel value as linear, the test data accuracy is 0.94, and for parameter value like c parameter value is equal to 1 and kernel value is poly, so this is the accuracy. So this is basically the test data mean test accuracy for the different combinations of parameter values, so which I hope you can understand this. So in the code the different c values that we have tested are 1, 5, 10, and 20, and these are the 4 kernel values, so linear, poly, rbf, and sigmoid. So those are all the different combinations that we have. So for first, like for firstly what happens is like for this c value of 1, all the combinations of kernels will be tried, and for c value of 5, again all the combinations of kernels will be tried. So this will be done for all the different c values, and out of this we are just going to find which combination has the highest accuracy. So here c value of 10 and linear has the highest accuracy of 95.2%. So that's what we have printed here. Okay, so this is how you can interpret the grid search cv results, and you can interpret this in data frame, and you can print that in this highest accuracy. So I'll just create a text here, and I'll just put that for this support vector classifier, the highest accuracy that we are getting is 95.2%, and the best parameters for this support vector machine are best parameters is equal to. So I'll just create something like a dictionary here. So for C, the best value is 10, and for kernel, the best value is, we know that it's linear, right? Linear. Okay. So I'll just include this in quotes and put this like this. Okay. So the highest accuracy that we are getting is 95.2, and the best parameters are C is equal to 10 and kernel is equal to linear. So this is GridSearchCV. Now we are going to do all the same procedure for randomized search CV as I've told you. So instead of trying all these, 16 combination from 0 to 15, so we have 16 combinations. So because like we have 4 C values, 1, 5, 10, 20, 4 different C values and 4 different kernel values. So instead of trying all these things, we will randomly select few parameters value and do this same procedure. Okay, so this is called as randomized search CV. So I'll name this as randomized search CV. Let's just make these letters bold. Okay, so I'll just go here and create a section for this grid search CV. Okay, so grid search CV. So if you just create some text and you put hash symbol here, so this will create a section like this, and it will enclose all the cells below that particular section. So this will make your code more concise. I'll just create this randomized search CV as another section. So you just need to include a hash here. So I'll just go to the top. I can just compress all the cells to this particular section. So this is the second section. So grid search CV cells will contain the code for all the procedure that we have done using grid search, and for this randomized search CV that we are going to work now. So I'll just expand these cells. I'm just going to copy all the things. So the only difference that we are going to do is, instead of grid search CV, I'm going to use randomized search CV. So we are not going to do anything other than that. So we can just copy all the cells and we can just uh, you know change it to randomized search CV. So let me put it here. So first we are loading, again we are loading the subprotector classifier, because we cannot use the same model because it is already trained on the data. So we are creating a new thing called as a model, new variable called as model, and we are loading the instead of subprotector classifier. And now we need to mention the hyperparameters. So this can be like, you don't need to do this parameters because it's kind of the same, but I'm just doing this so that you don't get any confusions. So these are all the different parameters that we are going to work on. And now I'm going to create a randomized search. So instead of this, so this is where the code changes. So instead of grid search CV, we have to change this to randomized search CV. So apart from that, all the things will remain the same. So classifier, I'm going to use randomized search CV. So we have imported this randomized search CV from sklearn.model selection. I'll just copy this and paste it here. So randomized search CV. So we are having the model, and the parameters that we are going to consider are present in this dictionary. So it should be in this format. So other formats probably won't work. So you have to give this in the form of a dictionary, and then CV is equal to 5. So let's run this. And the next thing that we have done is, to fit our data, right? So we are going to fit the data to our model. So here we are not doing grid search CV, we are just doing randomized search CV. Okay, so classify.fit x and y. So let's run this. As we have seen, this might take some time, so we can see. Okay, so the next step that we have to do is print the classifier results. Okay, so classifier.fit. So this is like classifier.cv results, which will give the cross validation results. And we are going to print the best parameters that are determined using the randomized search CV. Classifier results, best parameters, and highest accuracy is the next one. So CV results, highest accuracy. So just copy all these cells and put it together. So this cell, this one. So we are just loading the data to a data frame. So result.copy. Grid search results. So let's rename that later. Okay. So I'll just paste all the cells here. Okay. So now let's just, so let the code run. So I'll just change the value. So classify.paste best parameters, highest accuracy. So we are just creating I'll just name this as, okay, so let this be result. So let's change this grid search result to randomize the search result. Randomize search result. We are going to print that randomize the search result. Okay, so now let's see. I think the Yeah, so the classifier has fitted to our model. So we can see, so instead of GridSearchCV, now we have this RandomizedSearchCV. So cross validation is equal to 5 estimator. So the model we are choosing is protected classifier. So this is the distribution. So the different combination of C value and kernel value that we are taking. So apart from this, there are also other hyperparameters. So you can also try those parameter as well. So here we have just used two hyperparameters, so you can combine more parameters as well. So that's not a problem. So the model has fitted to our data. I'll just run this classifier.cv results, which will print my result. Okay, so now you can see here, in the previous case we have several combinations, right? So we have different combination, about like 16 combinations are there for the different parameter values. But in the case of randomized search cv, you don't have that many combinations. So the randomized search cv will randomly choose only certain set of parameters. So it will just randomly choose, so hence the name, so that the training doesn't take that much time and it doesn't take that much resource of your computational power. So that's the idea of using randomized search cv instead of this grid search cv. So let's find which is the best parameters. So in this case also, the model has rightly found that the best parameters are linear kernel and c value of 5, and the highest accuracy will probably be the same, because like we are not changing the parameter values here, right? So that's the reason. So we are loading the result into a data frame, we are printing it. So finally we are just choosing only the c parameter, kernel parameter, and mean test score. So let's run that, and let's run this data frame. So as you can see, so this data frame contains only like 10 combination, right? So it doesn't contain all the 16 combinations, so we just have 10 combinations. So like this may seem like it is not a big difference, but in some cases you may have to deal with like even more number of combinations. So in that time, your hyperparameter tuning will take a huge amount of time. So that's why we can choose between GridSearchCV or randomized cv. So here also the best parameters that we got are kernel is equal to linear and c is equal to 10. Okay, so just copy the text from here. So this is the result that we get from GridSearchCV, and now we are going to put that here as well, because like we are arriving at the same conclusion, right? So highest accuracy of 95.2, best parameter of c is equal to 10, kernel is equal to linear. The only difference is that accuracy are determined by GridSearchCV, and this one is determined by randomized and here the main thing that you need to remember is, all the time you like the result won't be the same. So like the idea here is like GridSearchCV doesn't exclude any combination of parameters, right? So what happens is, like, so we know that 10 and linear are the best parameters. So when randomized search CV is running, it may skip that part. So it can you can see here, so 10 and linear, so it can like skip that particular parameter combination, and it will give us a different accuracy as the highest accuracy. So that's the drawback of this randomized search CV, whereas GridSearchCV will try all the different combinations. So the idea is, like, in this case we got the result as same for both grid search and randomized search, but it won't be the same in all the cases. I want you to remember this is like very very important. So the reason that we have this two kind of techniques is, as I've told you before, in some cases you may not have the computational power, you may not have the resources to try a different set of parameters, different combination of parameters, because the main thing that you need to remember is, in this case we have tested for only one model, which is subprotected classifier. Often what we will do is, we will take 5 or 6 models, and for each of this model we will do hyperparameter tuning, and we will determine which model with which parameters we are getting the highest accuracy. So that is like computationally larger and a more complex problem, and it will take so many computational resource and time as well. So it will take a huge time to run, and in that case, so instead of going with grid search cv, we will go with randomized search cv, because we are not checking for all the combinations. We are just randomly choosing some with a hope that we will arrive at the highest accuracy. So that's the idea. So if you have a small data set, if you don't have that many hyperparameter combination, you can go with GridSearchCV. But if you have different models that you have to check and different hyperparameters that you have to check, in that case you can go with randomized search CV. So this is the important thing that you need to remember. Now what we have to do after this is, so like we are getting c value as 10 and kernel value as linear, right? So this is not the end. We are just searching for the best hyperparameters, but we haven't trained our model yet. So we haven't like completely trained our model yet. So these are all kind of the evaluation. So the prerequisites that we often do. So now what we have to do is, so you can just go to this x and y that we have splitted before, right? So you can see, yeah, so the x and y, now you can split this x and y into training data and test data. After that, you can create a variable called as model, and while loading the supported classifier, in this we will mention c value as 10 and kernel value as linear. So this is where you will use those hyperparameters which have the best accuracies. So what we are basically doing here is we are trying different combination of hyperparameters values. Once we determine that optimum parameters for which we are getting highest accuracy, we will split our data into training data and test data, and then we will train our supported classifier with those specific hyperparameters. So you can see, so we have c and kernel values, right? So we will train with c value as 10 and kernel value is linear, and after that we will do the basic evaluation and other things and so on. So this is how you have to work on this. And yeah, I hope everyone understand until this part. So that's it from my side, and I'll see you in the next upload. Thanks for watching.